the derivative as a function. The derivative of a function f of x with respect to the variable x is the function f prime, whose value at x is f prime of x equal to limit as h approaches 0 f of x plus h minus f of x divided by h. Here we have graph of our function. We have these 2 points PQ. Find the slope of this secant line, that is equal to change in y divided by change in x. So that is equal to f of z minus f of x divided by z minus x. So based on that, derivative of f at x is f prime of x equal to limit as h approaches 0 f of x plus h minus f of x divided by h. And that is equal to limit as z approaches x f of z minus f of x divided by z minus x. So what we did here on this part is based on h equal to z minus x in denominator, and from this part z is equal to x plus h. So this one x plus h, that is z. Now here on this part, slope of this tangent line is equal to limit as h approaches 0 from left. So here this point is b plus h, and here on this part h approaches 0 from left. So here we have b plus 0. So our limit as h approaches 0 from left, f of b plus h minus f of b divided by h, that is our slope. And here on this part, slope of this tangent line is equal to limit as h approaches 0 from right. So this one from right. Here we have a plus h, and here on this part we have a plus 0 because h approaches 0 from right. So limit as h approaches 0 from right, f of a plus h minus f of a divided by h. That is our slope. Alternative formula for the derivative, f prime of x, that is equal to limit as z approaches x, f of z minus f of x divided by z minus x. That is what we had here on this part. And based on this theorem, if f has a derivative at x equal to c, then f is continuous at x equal to c. Examples, find ds divided by dt. That means we have to find s prime of t if s is equal to t divided by 9t plus 8. So we have to use this formula to find s prime of t. So the first step is finding s of t plus h. So what we have here is that is s of t. So when we're trying to find s of t plus h, that means instead of t, we have to use t plus h. So in the numerator we have t plus h divided by 9 times. Instead of t, again we have t plus h and then plus 8. Now simplify, so use distributive property in the denominator. We have 9 times t, 9 times h. So this is equal to t plus h divided by 9t plus 9h plus 8. So s prime of t is equal to limit as h approaches 0. S of t plus h, that is equal to t plus h divided by 9t plus 9h plus 8 minus s of t is given here on this part is t divided by 9t plus 8. And then divide by what we have in denominator is h. So here on this part we had h in denominator, that is same as multiplying by 1 over h. Now here we have common denominator 9t plus 9h plus 8 multiplied by 9t plus 8. And based on that, our numerator is t plus h times 9t plus 8 minus t times 9t plus 9h plus 8. So we have to multiply t times 9t, t times 8, h times 9t, h times 8. And same thing on this part, we have to use distributive property. After we multiply, we have to combine like terms. So here, combining like terms, what we have in numerator is 8h. Simplify, we can cancel h. And now what we have here is 8 in numerator. Now finding limit as h approaches 0. So here, for h we have 0. And what we have in denominator is 90 plus 8 times 90 plus 8. So that is 90 plus 8 squared in denominator. So here is our final answer, 8 divided by 90 plus 8 squared. Differentiate the function and find the slope of the tangent line at the given value of the independent variable. F of x is equal to 4 times x plus 5 divided by x, and x is equal to -2. So we have to find f prime of x first. Find f of x plus h. So using f of x that is given here on top, instead of x, use x plus h. So this is equal to 4 times x plus h plus 5 divided by x plus h. So f prime of x, that is equal to limit as h approaches 0. Here, this part, that is f of x plus h. Then we have to subtract f of x, which is given here on that board. And finally divide by h. So here our denominator is x plus h, and here we have x. So I'm going to multiply both numerator and denominator by x times x plus h. So here in numerator I multiplied and simplified. So what we have here is 4x times x plus h squared plus 5x minus 4x squared times x plus h minus 5 times x plus h. In numerator and denominator is x times h times x plus h. So here on this part, first find what we have for x plus h squared and then multiply by 4x. And here, using distributive property, so this is what we have in numerator. Now we have to combine like terms. So what we have in numerator, after combining like terms, we have 4x squared times h plus 4x times h squared minus 5h. And denominator, xh multiplied by x plus h. Now factor what we have in numerator, we can factor out h. So I canceled h from numerator denominator. So what we have in numerator is 4x squared plus 4 times x times h minus 5 divided by x times x plus h. Now finding limit as h approaches 0. So here, instead for h we have 0. So in numerator we have 4x squared plus 4x times 0 minus 5. And denominator is x times x plus 0. So that is equal to 4x squared minus 5 divided by x squared. Simplify. Our final answer is 4 minus 5 divided by x squared. Now we have to find the slope of tangent line at x equal to -2. So the slope of tangent line at x equal to negative 2 is f prime of negative 2. So using what we have here, 4 minus 5 divided by over x is negative 2. So this is equal to 4 minus 5 divided by 4. Here we have 16 minus 5. So our final answer here for this part is 11 divided by 4. So this is the slope of tangent line. Find the indicated derivative, then find an equation of the tangent line and the indicated point on the graph of the function. So here y is equal to 7 divided by square root of x minus 1. And our point is 2, 7. So finding f, so f prime of x, that is equal to limit as h approaches 0. Numerator we have 7 divided by square root of x plus h minus 1. This is what we have for f of x plus h. Then subtract f of x, and that is what is given here on this part. 7 divided by square root of x minus 1. And finally divide by h. So here what we have in denominator, square root of x plus h minus 1 and square root of x minus 1. So multiply both numerator and denominator by square root of x plus h minus 1 multiplied by square root of x minus 1. So after multiplying numerator denominator, what I have here in numerator is 7 times square root of x minus 1 minus square root of x plus h minus 1, and denominator h times square root of x plus h minus 1 multiplied by square root of x minus 1. Now multiply both numerator and denominator by square root of x minus 1. Here we have subtraction instead, I will use addition. So plus square root of x plus h minus 1. So what we have here, after multiplying square root of x minus 1 minus square root of x plus h minus 1 by square root of x minus 1 plus square root of x plus h minus 1, we have x minus 1 minus x plus h minus 1, and we have to multiply by 7. And rewrite what we have in denominator. Now simplify our numerator. So combining like terms, here on this part, our answer for numerator is negative 7 times h. The next step, we can cancel h. So what we have here, numerator is negative 7. And now finding our limit as h approaches 0. So instead of h, we're going to use 0 in denominator. So here instead of h, we have 0. So here is what we have for this part. Now we have to use what is given for x. Now we have to find f prime of 2 for x equal to 2. So based on what we had here on this part, this is equal to negative 7 divided by 2 times. Instead of x, we have 2, so 2 minus 1, multiplied by square root of 2 minus 1. So the answer here on this part is negative 7 divided by 2. So what we have here, y is equal to negative 7 divided by 2 times x plus b. Now we have to substitute what was given for our point, x was 2 and y is 7. And then solve for b. So here substitute 2 and 7. For y we have 7 and for x we have 2. Simplify. Here is 7 equal to -7 plus b. Solving for b, b is 14. So this is what we have on this part. So the equation of the tangent line at 2, 7 is y equal to -7 divided by 2 times x plus 14. Find the value of the derivative. Y is equal to 5 minus 4 times x squared, and x is -3. So here on this part, f of x plus h, that is 5 minus 4 times. Instead of x, we have x plus h. Then square minus f of x is given. It's 5 minus 4x squared. And then finally divide by h. So here first find x plus h squared. Then multiply and subtract what we have in numerator. So these are our terms. Now combine like terms. So in denominator we have h, and numerator I combine like terms, and we have -8xh minus 4h squared. We can factor out h. So I cancel h, and here we have -4 times 2x plus h. Now instead of h, we have to use 0. So -4 times 2x plus 0. And that is -8x. So here is our answer for this part. Now we have to use x equal to -3 to find the final answer. So finding f prime of x is -3. Finding f prime of -3, that is equal to -8 times -3. So the final answer is 24. Use the alternative formula for the derivative to find the derivative of f of x equal to 5x divided by x minus 2. So here we have to find limit as z approaches x of f of z minus f of x divided by z minus x. And here, in this case, f of x is 5x divided by x minus 2. So finding f of z, instead of x, use z. So it's 5z divided by z minus 2 minus 5x divided by x minus 2. And here in the denominator we have z minus x. Now based on what we have here, z minus 2 and x minus 2, multiply both numerator and denominator by z minus 2 times x minus 2. So here I multiply and simplify what they had in numerator. So numerator we have 5z times x minus 2 minus 5x times z minus 2. And multiply all that we have here in denominator. And now use distributive property, multiply, and then combine like terms. The combined like terms, we have -10z plus 10x here on top, numerator. Factor out -10. Now what we have in numerator is -10 times z minus x. So we can cancel this part. So what we have here on top is -10 divided by z minus 2 times x minus 2. Now finding our limit, instead of z, we will use x. So x minus 2 times x minus 2. So this is equal to -10 divided by x minus 2 squared. So this is our final answer, meaning that the derivative of f of x equal to 5x divided by x minus 2 is negative 10 divided by x minus 2 squared. Show that the function y equal to absolute value of x is differentiable on negative infinite, comma 0, and on 0, comma infinite, but has no derivative at x equal to 0. The derivative of y equal to mx plus b, that is the slope m. So to the right of the origin when x is greater than 0, finding derivative of absolute value of x, that is finding derivative of positive x. Because for absolute value of x, depending on what we have, what values we have for x, if x is greater than 0, our function is equal to x. If x is less than 0, our function is negative x. So here for x greater than 0, absolute value of x is positive x. So this is 1 times x, and our derivative is 1. Now to the left of the origin when x is less than 0, our derivative of absolute value is equal to the derivative of negative x. So the answer for derivative is equal to negative 1. So we have negative x because here we have x less than 0. So absolute value of x is equal to negative x because of having x less than 0. So what we have here, based on graph of our function absolute value of x, right hand derivative of absolute value of x at 0 is equal to limit as h approaches 0 from right of absolute value of, instead of x we have 0, so it's 0 plus h. So this part is f of x plus h, minus here is f of x, and our x is 0. So absolute value of x is 0. Here we have absolute value of 0 divided by h. Now we have to simplify. So this is absolute value of h divided by h, finding limit. But the point is that if our h was greater than 0, we're going to have absolute value of h equal to positive h. So finding limit of h divided by h as h approaches 0 from right, that is equal to 1. And this is what we have here. Our y prime is equal to 1. And now what we have for left hand derivative of absolute value of x at 0, in this case, absolute value of h will be equal to negative h because of having h less than 0. Because here in this case, we move from left, the answer should be equal to negative 1. So y prime should be negative 1. Now here on this part, finding limit as h approaches 0 from left. So we're trying to find the left-hand derivative of absolute value of x at 0. So in this case, for when h is less than 0, our absolute value of h is negative h. So this part is exactly the same as what we did on top. Now absolute value of h is, in this case, is negative h. Finding limit. Here limit of negative 1 is equal to negative 1. Meaning that our y prime is negative 1. So what we have here, on left side we have negative 1, and on right side we have positive 1 for y prime. That means there is no derivative at the origin because the one-sided derivatives differ. Or in other words, there is no derivative at the origin because right-hand derivative is not equal to left-hand derivative.